Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
All right. Hello, everyone. Welcome back. It's time for the next session, and we have Adam Bean prepared for you. Adam is not a framework guy. I myself am a React developer. Well, I am a JavaScript developer that mainly does React projects, and Adam is like a purist, and I love seeing that. He just wants to stick to the core and use the platform, the power of the platform, without being dependent on some third-party thing like a React or Angular. And today he's going to be talking about how or why or if you should use the cloud and help you make some decisions. Really curious to see what that is because, well, running your own infrastructure is quite expensive. So let's see what Adam has prepared for us. Adam, the stage is yours. Let's go.
For the show that, going away from the bloated JavaScript and do something more with Java, to be more lightweight, but let's see how it goes. And in projects, indeed, we in the front end, we are using more, plain web components and JavaScript. But today is just about backends. So in January, I talked about front ends, and today about backends. Also, Matt asked me, is this session going to be about Java? I would say this, what I show you today, should apply to everywhere. But my observations come from Java projects because I'm Java developer. So I would delay the introduction to a bit later because I have dedicated slide for it. And what may be interesting is they are podcasts in HexFM. And there are workshops around the corner, also Java on AWS Cloud. Or even more interesting, I think Monday, next week, first Monday of the month, 8 p.m. CET, there's a question and answer show. You don't even have to register. You can ask, you can ask questions on GitHub Gist, and I will read them and answer them. Why am I doing this? Because I'm not answering emails anymore or technical emails, and this is a time saver. Okay, there are the workshops. The next one is July the 8th, but it's almost full, is to run Java application on AWS, all kinds of Java applications. Okay, so in my talk, in the title, there is an effective, and the question is, what effective actually means, right? Because it means different stuff for different people. So if you Google for definition effective today morning, at least, I got the following definition: successful in producing a desired or intended result. Now, which is true. And now the question is, my observation is, the larger the company, the less defined is the desired outcome. So what I already saw in projects is like where, and by the way, what I forgot to mention, what I really like is interactivity. If you have questions, please ask me during the show. I really like, to answer them. Otherwise, I could pre-record this session in advance and send and upload that. It would be just boring. So feel free to ask questions. We should use the platform. So the larger the company, the less the desired outcome is defined. And sometimes the larger companies, we get strategy, go to the cloud and ask why. No answer. Yeah, because we have to. And this because we have to, I think, is a little bit problematic. And this is the idea of this talk. So if you do something, you should know why, and not just do it because you do it. And in smaller companies, startups, they exactly knew why, or it turned out to be the best possible solution to use public or private cloud, or even both. Okay, so this is my slide from the microservice workshops, what I did back then. And I just reused the slide, and it is, I think, 6-7 years old picture, and it is 2013 exactly, because back then I wanted to buy this Sun E10K to have a storage for my clothes because it was cheaper than IKEA. And what I wanted, because I really liked the servers in 2000s, E10K, Sunfire E10K, huge machines. and the origin costs were 1.2 millions. And I used this slide to explain the economics of shared deployment model. So back then, application servers like Java EE or J2EE, there was no Java EE, J2EE application servers. The idea was to save costs, hardware costs, because you installed one server on 1 million machine and could run, 10, 20 apps on this machine. So the applications or departments could share costs. This was the idea back then. And what I told usually is, even 2013, this is when the microservices started, is nowadays the hardware is so cheap that you don't have to do it anymore. So what I did probably 10 years or more. So I'm shipping one war on one application servers, and so there's one-to-one relation, right? So why this is relevant, you will see in a second, because it is similar to the cloud, what happens right now. Okay, so this is also relevant, and this is the introduction, my introduction, right? So how I started with Java, and it's also my observations. So I actually started with Sun Java Web Server, which is the later came servlets were standardized, and before that there was not even XML. So the first projects were run on that, and in the year 2000. Exactly in 2000. I look it up today. So the first edition of the book Java and XML was in June in the year 2000. And I was at Java 1 back then. It's a huge conference. And so they announced the book. And then, we got early J2EE, lots of XML. And the XML was massive. So we had standard deployment descriptors, and we had also, the proprietary deployment descriptors. So we had lots of deployment descriptors. And this was caused by this book, Java and XML. So I like the cover, but I don't like the idea of the book, because I was forced back then to write a lots of XML, which I didn't like at all. So this was fixed by a tool called Xdoclet, and there was hype called attribute-oriented programming, not aspect, attribute-oriented programming. And the idea was you put some annotations in Javadoc, and then the XML is generated for you. And people argued, problem is solved, because we get the deployment descriptors generators. Except, if you think about this, something is wrong about the idea. Why? Because you have now the truth in two places. So you have, if you can generate something out of Java code, it is already suspicious, because it means, why you're able to generate that. And this was fixed because as an idea from Xdoclet, and by the way, you can listen to my podcast, Airhacks FM. So I had several interviews from back then, how everything happened. So if you like, listen to it, Airhacks FM. And the Xdoclet tried to solve that. And what happened then? Annotations happened in Java. So what annotations were the observation, what you can actually do, puts an @ sign, on the method, and not it would just type safe and not, fiddle with the Javadoc. And you get the same amount of information, and then basically this killed completely XML. So since Java EE, we don't have any XML, so there's convention of a configuration, but we still have shared deployments. So with microprofile, came 5 years ago, I think, we have no XML, we have a little bit optional configuration. If you like, you can write property files or not, and everything is Kubernetes and cloud native. And we get some cloud features like open metrics, open API, JSON Web Tokens, and everything comes out of the box. So now, if you add cloud to the mix, what happens? We don't have XML, but we get a massive amount of JSON or YAML. So basically, if you have Kubernetes, you have a little bit of YAML. I mean, it is comparable with XML back then, except, you have to be very explicit with. If you ask me, I would prefer XML than YAML. So it is less error prone and easier to validate. You get, but, forget it. So it's not like XML should not come back. It's just now the observation. And if you use something like AWS CloudFormation, you get a massive amount of JSON. So I would say, in a simple microservice, the description is longer than the actual service. So this is at least in Java, from Java perspective. So and what we got right now is late Jakarta. I mean, now we have no XML, lots of generated YAML. Why that? For instance, there are a Kubernetes tool like Helm, which have templates to generate, the code for you. So actually, exactly what you did 20 years ago with Xdoclet, now it happens again in the cloud. And if you don't do this, you are writing infrastructure as code. So what's the difference, ISC and like Helm? So with Helm, you are generating the deployment descriptors right away. And with infrastructure as code, you are talking usually via the public API of the clouds and do something behind the scenes. Nonetheless, the amount of necessary plumbing is huge, actually. So if you use something as nice as Terraform, there are still templates with 500 lines of code just to ship a simple container with some or a Lambda function with an API gateway. So this was the basic introduction. Let's see whether we have any questions. No questions. Then next slide. So now, what I also noticed, that the expectations of public clouds are completely wrong. So this is like, what developers, managers, and clients expect from cloud is actually the opposite would happen. So what I expect is basically no plumbing. If I show them what you have to do to deploy, an infrastructure as code like service to the cloud. Oh, by the way, what I forgot to mention here, of course, I have it here. Everything started with DevOps. So what I remember, I forgot to mention that. What I remember back then, we were in charge of ordering the machines, the servers, or at least we suggested the servers and the entire infrastructure. So we cared about, from hardware to installation to software. And then in the J2E days, it disappeared because there was like the role model, and now it comes back. There was no term DevOps. You were just backend developer or host master. Maybe, the DevOps was the host master. I think it was called host master, webmaster, not host master, webmaster. You were the webmaster and you did everything. Okay. Now the expectations right now is no plumbing. So no one expects to write an extensive thing. And actually, you can absolutely use the console, the portal. So Azure portal or Amazon console. And this is way more convenient than infrastructure as code. Why is the case? Because lots of stuff is generated behind the scenes for you, which you don't see, like permissions, for instance. Now, what people also expecting is single-click deployment. So like, okay, now we have the application and we ship it. And by the way, I remember the first Java projects on the Sun E10K, the term application server in a company, it was insurance. People came to me and say, we have application server. Can we just install Word on it and spread it? So this was the expectations. Like, now we have Java, everything is easy. And the idea that the application servers do like they auto-magically reinstall or make, Word, Microsoft Word, web capable. So this was, the ideas I have to deal with back then, 20 years ago. And now I get similar, expectations for the clouds. Then automatic scalability, which is partially true. So if you use, for instance, Amazon or Lambdas or Azure functions or Oracle functions or AWS Lambda, then scalability, there is no scalability. They will just, you don't have to think about the machines. They will just, be executed concurrently. And if you have, a massive amount of load, you will have to call, the support and just open the gates, and then it will scale massively. So the question is, what if you don't have Lambdas? What happens then? Well, what do you have to do? Usually, you have to provision a machine, a virtual machine, and decide from the one how many visual CPUs or RAMs or we need. And on this machine, you get install, for instance, Kubernetes or other stuff. So everything starts with the machine. And if you take a look at the beginnings of the clouds, so like Amazon, so they started with S3, EC2. S3 is a simple storage service, and now it will be probably called a serverless storage service, but it was simple back then. Then EC2, which was the virtual machine images, and SNS, I believe this is simple notification service. And these were the three services. And if you take a look on everything else until recently, you will recognize that everything is built upon these primitives usually. So, So automatic scalability, you can get the automatic scalability. The truth is, so this is like, we have to go to cloud to scale. So the interesting truth is, in my projects with application servers, usually they were way faster than expected. I remember a couple of projects, 5 to 10 years ago, where we had several thousand transactions per second without any fiddling with anything. Just, it was just, back then it was stock Glassfish without any major optimizations, just reasonable settings for instances, and they run forever. And they're still running. So recently I got an attendee for a workshop and asked them to say, yeah, they're still happy. So it means, for decent machines and for instances on premise can deliver decent performance, which is good enough for boring enterprises, but it's not good enough for Netflix, YouTube, Facebook. So, and this is maybe, so effective cloud strategy for a company. So this talk only applies to you if you are like me, you're spending your time in more or less boring projects, not like you would like to take over the world and you expect 1 million transactions per second, right? It's more like you have, an older applications, enterprise application, and you would like to modernize that. So this is the idea. So automatic scalability, it is a feature, but I don't think it is the most useful feature of the clouds. Agility is more interesting. So what you really can do if you automate everything, you can start and stop, you can create or provision the entire cloud and delete it in about 5 minutes. So 5 to 10 minutes. It depends what resources you are using, and the low cost is also an expectation. So people expecting that the clouds are cheap, and we will come to this later. What cheap means depends on the, I would say, business and the use case, and ease of use. So if of ease of use, I wouldn't say that clouds are easy, and you cannot say it in general. But in my enterprise projects, if developers are talking to me, what they usually think about cloud is usually Kubernetes, and I would say setting up an application which runs on Kubernetes is plumbing. Right, so there's no difference to back then to write XML. You have to know to repeat the name of the service. You have to specify the ports, the health checks, whatever you did in Java code, you have to repeat in YAML. So there is actually, and by the way, there is even a service, a utility very similar to Xdoclet called, I think, Decorate. And what it can do, it can generate YAML from Java code. So exactly what happens Xdoclet 20 years ago. So, what this also somehow, I don't know how, but the expectation is if you go to the cloud, microservices is the thing to do. And we'll come to this later. So, I would say almost this slide should be cloud fallacies, not expectations, but this is, yeah, by the way, do I have any questions? Or the audience is still with me. Everyone, this is interesting because usually there's more discussion about this. So now, Kelsey Hightower, who is a very skilled developer, says Kubernetes is a platform for building platforms. It's a better place to start, not the end game. And this is, for me, Kubernetes is very similar to Linux. So it's not like, I like Linux, but it's not like I'm very excited every day that I have Linux, right? Kubernetes is the same. I would really compare it both. And what it says is, no, Kubernetes will never meant to run applications directly on Kubernetes. Why not? Because it is not hard and not complete. For instance, you don't have ingress controller, you don't have a Docker registry, so you will have to do something on top of Kubernetes to make it usable. But if you are building a platform, what is platform? You own cloud, Kubernetes is perfect. So what we usually did in projects, because of laziness and productivity, we used OpenShift on premise instead of Kubernetes, and OpenShift is Kubernetes, but with more convenience. So there's like, what comprises OpenShift is HR proxy as a load balancer. There is a backed-in Docker registry, and you get a nice secured, admin console. So it is Kubernetes with more convenience. And so I think I just run Kubernetes for fun on my machine, but never in production directly. And I only know one company which uses Kubernetes on premise. Okay, so what means is Kubernetes is very important as a platform, like OSGI, I would compare it, right? So this was why I always used OSGI without knowing, because all application servers were OSGI based, and I never used OSGI, or I try to avoid OSGI in my business projects because it was pointless. But if I would build my own application server, I would use OSGI. So this is the comparison. Now, the first idea, what you can do, I have to find my browser. What this is called Payara Cloud. And I told you shared deployment model is dead and so forth. And there are now for years they are blocks like application servers are dead. And what is that in application servers? What I didn't use for 10 years is a shared deployment model. And what I didn't use for years was the clustering, because we had Docker container, and you can start and stop applications very easily in Docker container, and you don't need a cluster anymore. With HR Proxy or Nginx, you get your own cluster. And stateful EJBs, no one care about that. And HTTP sessions, sometimes you have them, but you have sticky sessions. Well, this is genius what they did. What this does is, so the Payara Cloud is basically an application server, and the Payara usually used Shoal to manage the instances. And now the Payara admin server, this is at least my understanding, I'm not building this, is what I saw so far. And the Payara server is Kubernetes operator. So what it means is the Payara server manages Kubernetes for you behind the scenes, and you don't have to bother with all the details. And what happens behind the scenes is the Payara master, the Payara server, starts and stops little Payaras called Payara micros, and they are the pods, which happens automatically for you. So this is not the point of the session. I just there was several conferences where I tried that. I was just curious how it works. So you get some basic. This is preview, by the way. It is and you get URL. You got a custom names, and how you would deal with that is if I just go set up Jakarta EE project, and let's say it. Cloudfish. So this is my old template. I use, Cloudfish. And then if I would switch to here and say Maven clean package, I would get, let's J11 maybe, Maven package. Hopefully it works. Wow, it works. And target, and I get the war. And the war is just like, this is just a template. It's just a REST endpoint with, I think, metrics. So there is not a lot behind, but I can show you how it works, how it looks like. Wait a sec. But this is actually a template from projects I used now and back then. And you have just the two dependencies, and there is the JAX REST configuration and basically ping resource with add pass ping, some micro profile config configuration, and this is the endpoint that this basically it's. So you get dependency injection for free. You can configure this, which is overridden by Kubernetes or containers, and it just works out of the box. So it means this thing is completely cloud native, if you like. But I don't even understand what cloud native means, because all my servers were always cloud native, but we don't have enough time to talk about that. So now, if I go here and take a look at the size, you hear 4K, which is good. So I would like to open that. Okay, now I have it, and let's see. So what I can do is I can what I can do is I'm just thinking about whether I should deploy a new application or create an. So what I wanted to do is just to upload the war and then make it run, but we could upload new binary and just upload that and then see. Point is, the template is really old. It's hard to find. So what I will have to do is to leave here the full screen and then upload that. Actions, upload new binary, choose file, and then I can just do this. It's easier. So Cloudfish, open and upload. And now it will process the artifact, and you will see a new war is going to be deployed. And after a while, I can just call it. And the namespaces are just projects. So I can create a new namespaces, new projects here. So that's the idea. So what I could do, I can create here upload new application, delete the application, and create new namespace. And namespace project is similar to Kubernetes namespace. So what this means is, this is actually what I always expected from the clouds. Like, I have my application, I ship it to the cloud, and it should run. So such services are available, of course, only interesting for simple applications. But I think this runs on Azure. So you can talk to the databases. So it is very like, you can pick your own wars and ship them to the cloud without fiddling with any Kubernetes stuff. So I like the idea because it's genius. It is exact opposite to Quarkus, Helidon, and Micronauts. The idea is what they are doing. Therefore, what I like it, because the old application server is used as cloud orchestrator, which manages all the stuff for you. So the application is configured, and I won't call it. I recorded a screencast on YouTube. If you would like to see everything from scratch, just watch it. But this was just the entire life cycle, how to put the application to the cloud, and this is from speed unbeatable. Okay, so now any questions? No questions. So then, this is what happens in the clouds as well.
Adam.
You can actually buy or use Kubernetes on Azure called AKS or Amazon AKS. And the Kubernetes in the cloud, what it actually does is they are integrating with the cloud permissions, IAM policies, with block storage. There's something to do, so you get additional value. So if you run stock Kubernetes in the clouds, you will have to deal with the EC2 machines again, and you will have to restart the Kubernetes for patches. But if you are working with serverless Kubernetes, and what serverless means in a second, then you don't have to care about that. So it happens just behind the scenes for you. But you will still have, to use all the deployment descriptors and stuff in the background. And the question is why? Because there are other possibilities. So lift and shift. So this is another term, or rehost. And what this means is, I just picked, the definition from AWS. It means you pick your old application and just run it in the cloud. So this is what this would be. But this was usually meant, is not like you have Payara in between, rather than you will, ship the entire Payara to the cloud. This is what usually meant. So what this means for me, it is exactly the same like refactoring 5 years ago. You go to the business department and tell the people, hey, we have a project, 1 month project or 1 week project, doesn't matter. If we are lucky, after 2 weeks, your application will be exactly the same application available in the cloud. And the clients or users will ask, what's the point now? And you can say, maybe it is cheaper, maybe. And this is the question, is it cheaper or not? And from then, you gained nothing. So I would say I was not really, what we did in refactoring, we always coupled refactoring with additional features. So we never refactored just for the sake of refactoring, which was very popular back then. It still is. Rather than we said, okay, if we refactor the stuff, we will pick a user story or use case and just implement this during refactoring. So we get, after the refactoring, additional business features from the user. So I would say a puristic lift and shift is hard to explain to the users, but lift and shift with additional functionality could work. Okay. Now, the next. Are clouds killing microservices? This is an interesting one. So what you know, definition of microservices. Microservice is a process. So the idea is you have one process, one app, microservice. So now, if you think about this, every microservice comes with additional overhead. It is, regardless whether it's assembler, C, Go, Java. And of course, because Matt is again back, JavaScript diversed, right? Diversed overhead, just to make a little bit angry. And Java is, of course, the smallest possible solution. Just kidding, right? So, but what it means is you will have to pay for the overhead. So you're paying for the overhead. So what I already saw in the in one case, microservices. So we had an unreasonable monolith. So it was obvious that we can split it apart with added value. So we created from the one monolith 3 microservices, a smaller monolith. And then the question is, can we go to the cloud? And there were good reasons to go to the cloud. And then we did the math, and the management asked me, can we just not merge it back and make it a little bit cheaper? And I see it over and over again. So if you go to the cloud, everyone talks about microservices, but every microservices comes with an overhead. Every call of a Lambda function comes with an overhead. The more calls you have, the more you have to pay. And if you do it upfront on a calculator, no one will tell you, okay, go and deploy microservices. Funny enough, in one of the projects, I got only a small amount of IP addresses in a public cloud because they cost money. So I couldn't use. It was for me worst experience than before cloud. So, and this is the trend I'm seeing now. Now that actually monoliths are coming back because they are cheaper to run. The overhead happens only one, and it is also way easier to run. So the next problem is what I already saw with Kubernetes, because you have to pay per CPU and invocation time. Recently, I saw they're shipping an applications with the virtual CPU 10% of a virtual CPU, and max is 1 CPU. It means you get a Raspberry Pi is already fast. I mean, like Arduino-like experience. So what's the point if you have microservice with tenths of a CPU to save the costs? Okay. So what I'm thinking, what could be an idea to make a monolith application, which is a little bit larger and with more CPUs and cheaper to run, we don't know yet, but it is more easier to build and to maintain. That's the point. And there is far less configuration going on. There are no NAT gateways between, no network stuff, no ALBs, no load balancers, just a monolith. And I actually see it coming. So the next thing is monthly cost-driven development. So it's not we talked years that software development is expensive and maintainability is even more expensive. And now we got clouds and we have to do calculations to know which CPU is cheaper and which run is cheaper, which is okay. But this has impact on the architecture. So what I already saw, minimize the amount of calls to S3. So the simple storage server from Amazon, because they often you call it, the more expensive it gets. If you have one call with larger object, is better. So from the software perspective, is of course harder because you will have to gather the object somewhere else and put into S3. This is recently I wrote a blog, so it is interesting, right? Then use the least amount of virtual CPUs as possible, and they use the least amount of RAM as possible. So this reminds me, the old days of J2E. I remember a project I got 2 weeks time to optimize that the application server runs on 256 megs of RAM, because they will have to pay less to a different department. And say, hey, the machines are very cheap. Is it really worth? And then if I kept asking, they just increased the limit because it was pointless. It was way more expensive to pay me than buy some RAM. So and in the clouds, you have to be careful. No, in the case of Netflix, it's absolutely crucial, to save money here. But if you are putting your own microservice to the cloud, you have to think about why you're doing this. Would you like to reduce the monthly costs? Would you like to increase the productivity? Would you like, to increase the parallelity of the teams? But you cannot just go to the cloud and expect that everything is going to be better. That's the point. So, and this is a type of use cheaper storage. So what it means is on Amazon and similar to Azure. So if you use S3, it's the cheapest possible storage. If you use EBS, a little bit more expensive. EFS, even more expensive. And SFX, this is the most expensive. So I already saw what we are back to the Stone Age Java almost, where you have to deal with byte arrays sending back and forth. I mean, it's not that bad, but so this is interesting. So what I observe is that the software quality, simplicity, lean code, and whatever we talked the last 10 years, like what was it, software craftsmanship, goes a little bit back and is replaced with try to run the clouds cheaply. Now, effective cloud strategy. What you can do? I mean, it's not like clouds are bad. You should use them properly. So, and what this means for me is, if you have a boring application, I will keep, the boring application on premise. I will run it on OpenShift, even Kubernetes or Docker, do whatever you like, but I don't think it's a huge benefit. Or pick the applications and put it to the cloud. I don't think it is going to be cheaper. So what you can do is there are cost calculators, and I actually prepared something. So this is the Payara service and the AWS cost calculator, for instance. So you can have an estimate and say, I'm interested in Lambda, for instance. Configure and amount of requests. So how many requests do we have? And by the way, we need the without free tier, because in one point of time, BC, so we have 3,600 seconds per hour. Mal is multiplied by 24. So, and this is per day. Let's calculate per day. So this is per day. Duration in second. So if you use something like GraalVM in Java, let's Quarkus or Helidon with GraalVM, you can call the service in 10 milliseconds. But it's just, empty service. And the service will start and stop in 10 milliseconds. The problem is, what if you hit your database and you have a more expensive select statement, whatever, it won't be 10 milliseconds. I would say be realistic and let's say 500 milliseconds. So amount of memory allocated, 1 gig, I would say is maybe too much. But if we took a look at the calculation, it will call without free tier is $1, I think, per day. So if this happens, 1 invocation per second, so there is no parallel behavior, so nothing about, so of course we have 10, then we get 7 euros for 1 Lambda function per day. So the idea is, if we break apart a monolith, which I already saw in projects, to multiple Lambdas, so if you have 1 monolith, maybe you get at least 10 Lambdas, if not 100. So in 10 Lambdas is 70 euros a day, and because they have to call each other, right? So now make a different calculation, and if you something great in on Azure, and is called Azure Container Instances, container instance, right? So add it. So we have in US, Europe is a little bit more expensive. We have 1 container group. We have 1 second, 1 gigabyte, and 1 virtual CPU, and this will cost container groups 1 second. This is not 1 second per call. Is the amount of seconds? Is this actually is per the total amount of seconds? So and you will pay. Where is it? Like €1 per day. So what's not included is the Docker registry and the traffic and the IP addresses. So and I have just 1 service. So what we probably need is dev int prod. This you have to aware. Whether it's cheap or not, no idea. But you have to estimate the cost somehow, because everyone expects clouds being extremely cheap. So what I want to argue, what you have to do is what I tend to do is I create a proof of concept and run it for a day. It is faster and easier than trying to play with cost estimator. So then you see how much it costs. So then, if you would like also to be effective in the clouds, I don't like to launch the console. You will see it's very convenient to click through. The problem is you will very easily forget about the created resources. So what I will advise is to automate everything from day one. So you are able to spin up and spin down the entire services. And I would say no one cares about boring CRUD applications in the clouds. So I will leave them on premises. And so what's interesting on the clouds are the non-functional requirements. People saying, clouds are not secure. This is the opposite is true. If you're in the clouds, you have the unique opportunity to encrypt everything, and you can manage your keys, and you can rotate the keys, you rotate the certificates, and it happens automatically. It is really hard to achieve the same on premise. So I would say security could be a thing, to go to the cloud. And about additional cloud services, we will see on the next slide. And the future is serverless. What I mean by that, I think clouds became interested in the last 2 years. More and more services like Azure Container Service, ECS, Fargate, EKS are serverless, or even databases are serverless. What serverless means is there's a kind of a proxy which you don't have to pay for, or what serverless means is if you don't use the resource, you can reduce, the amount of active instances. You don't pay nothing. This is serverless. And someone invokes you will pay per invocation, per second, or whatever, but you won't pay the entire time. There's also the problem with Kubernetes in the clouds. Usually you will have to pay for the control plane per Kubernetes cluster. Okay, what the future is serverless means for me, so is usually what is way easier is don't forget about the virtual machines, just take a serverless service, and then you can present it to the business department and say, look, if we are using this way, it will cost us approximately this, and this is your decision. This is actually decision of development, whether something is cheap or not. And function as a service are great solution and a perfect integrator between environments. And by the way, Java runs great or as Lambdas, custom runtimes, for instance, what Micronaut and Quarkus and Helidon are doing. You can ship your old JAX2RS microprofile application, wrap it as Lambda, and start it. If you're interested, also on my YouTube channel, there is a session about serverless Java, I think is the title. So now on-premise colocation hosting. I think trend in the startups, they are moving out of the clouds to start on colocation. They just just rent fast hardware and install everything on it, which may be interesting. Should be cheap. We have years on experience in production, perfectly suitable for Jakarta. I mean, it just works. And additional features are really hard to implement, like machine learning, distributed storage, fine-grained security model, audits. High availability, disaster recovery, forget it almost, right? If you would like to build it by yourself, then go to the cloud. It's really hard. And regardless what you are doing, containers are a must. This is what I would say. And Kubernetes can help to run a large amount of applications. So in some projects, we are just using Docker. And in other projects, or in one project I know, they're using Kubernetes because they have more applications. So now, what is the killer user for the clouds? And I would say image recognition, text extraction, fraud detection, global caching, like use the global network, CDNs, text extraction, like an Amazon, Asia is called. I think I actually prepared this. So there are lots of Azure services which you can absolutely use even from your premise. So you can run your boring application on your container as you always did and just call out the service. In one project, we use the image recognition where they told us what's on the image. And you can use the form API. You can use, of course, the AWS calculator and form recognizer, which is called form recognizer on AWS. So you have a form and you get back a JSON, which is great. Before I built it myself, we did it actually, similar things. You will spend at least 3 days with plain Java on premise, or you get a better service and just call, per extraction, and you can present to the business. We actually delivering added business value. Then what we have, this is, you saw computer vision. There is computer vision, for instance, very similar service. So you can upload the image, and what you get back is actually description what's on the image. Also, sometimes needed. In one project, we had to recognize what's on the picture, and the question was actually to me, can you use OpenCV for that? So we could implement this or go to the cloud that's already ready to use. And so that's the basic idea. And you have certificate.
Adam,
great.
Adam,
hello. And encryption and Rust, DNS, and CI/CD and IoT. So this is, I would say, just use the killer features of the cloud and don't bother, with boring workload. So this is the last slide. If you like, see you next week with more code. We just deploy to cloud all the time. And I think next year I will do an Azure workshop. This year AWS, I have no time because I'll spend my time in projects. So, and in December, another one. Thank you. And there were no questions, Matt.
Yes, there were. Can you hear me, Adam? I tried to interrupt you a few times. But no worries.
Now the first time. This is the first time I can hear you.
Okay, no worries. But the questions are in Swapcard, not in the stream application you're using, remember? So there are some questions, but we don't have time because you ran out of time. So if you would log into Swapcard and answer the questions in the chat there, that would be great.
Let's do 5 minutes extra.
Yeah,
Clemens, okay.
Yeah. So first question is from Michael. Do you have a personal favorite public cloud provider? And if yes, why do you prefer that one?
Okay, so Asia is newer, and they are catching up. They are friendlier, and it's a nice one. AWS, they started in 2006, and what I like about AWS is they never disabled a service. Whatever they introduce, it runs forever, which very reminds me of the Java strategy. So I can rely on that all services are available, and AWS is huge. And Google GCP is one, I would say. GCP is from the technology perspective, and Kubernetes, invent of Kubernetes, is also know large companies running on GCP, but Google is not famous, for not turning down the API. So you have to have more argumentation with the clients. And Oracle Cloud is highly underestimated. It's actually great service, but less popular among companies. So I spend a lot of my time in Asia and AWS, and the reason is I don't have to argue among my clients. So if I'm a consultant, so client asks me for cloud, I say, okay, what do you like, AWS or Asia, and then we do it. So usually they're interchangeable.
Yeah, all right, thanks. Next question is from Rafa. It is, hi Adam, big fan from Brazil, so that's nice. What do you think about native compile with GraalVM and frameworks like Quarkus and Micronaut for cloud development? Do you think they are the future for Java's cloud sustainability?
It is a must. So in current project, we started with JVM on Lambda, and we show actually if you would like to, if you introduce GraalVM, you will only pay a tenth of the costs because it feels like C. So I would say it depends on your model, right? If your application runs all the time, a monolith on EC2 is matters less. If you're thinking about serverless models, you are paying for the invocation time, so you will be able to save a substantial amount of money with GraalVM. It's just about your economics and how you run it. But so if you're running as Lambda, use Graal.
Okay, cool. Another question is from Kamran. J2EE and application server were standardized by one company. Now there are too much players on the market. Do we need a design and cloudification also standards like J2EE?
Very good. J2E were not by one company, lots of companies, and this was the problem why Jakarta E came too late, because lots of companies who participated were not more available, and Oracle couldn't just donate the source code. This was the idea. But back to the question, what I forgot to mention, great question, thank you. That actually Kubernetes matters less in the clouds. This is my because if you build your own platform, you have to use Kubernetes. If you run in the cloud and you run on ECS Fargate or ACI, Azure Container Instances, these both services are far more convenient, require less configuration than Kubernetes, and are even cheaper because you don't have to pay for the control plane. For you as a developer, you always have to ship a container image, whether it is orchestrated by Kubernetes or something else. I personally don't care. And I'm of course, if I'm running on Azure, I'm a little bit dependent on Azure. So the deployment descriptor is like 20 lines of code, but it is easy to fix. So I would say in public clouds, in my projects, Kubernetes is an exception from the rule, and we use something like ECS Fargate, Lambda, Azure Container Instances, or app service. Yeah.
All right, Adam. Thanks a lot for this extra time. I now have to skip to the next session. So thanks a lot for joining us here today and teaching us all about the cloud. Hope to see you again soon.
Yeah, thank you a lot. Thank you for your time.
Bye-bye.
found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.